Dr. Bhaskar, Assistant Professor, Department of Computer Science and Engineering, Anna University, Chennai. Area of specialization is software engineering and database system. Guided more than 12 research scholars, published more than 40 national and international papers. Is a reviewer and editorial board member in international journals.
Welcome to the UGC lecture series in computer science. In this series of lectures, we have been looking at a particular subject which is called software engineering. And in software engineering, we have been looking at software testing in detail. In the previous session, I have discussed about a particular class of testing which is called black box testing. That is, without looking at any structure of code, if you are able to write certain level of test cases, it is called a black box testing. By understanding the problem, we have derived three different classes of testings. One, boundary value analysis, two, robust, and three, worst case testing. So this we have discussed in the last session, and for today's session we will be discussing on alpha testing, beta testing, functional testing, boundary value analysis, equivalence class testing, and decision tree based testing. First we will look at what alpha testing means. The alpha tests are conducted at the developer site by a customer. Say for whoever it might be, if you are developing a software for your own consumer or customer, the customer will sit in the developer site and will ask us to test for certain number of parameters. So those tests we will call it as alpha testing. These tests are conducted in a controlled environment where the developers would have given an intention of, given these set of constraints, this programming would work better. Say as far as our student result management system is concerned, having mentioned more than 50 as pass, 50% anything which we get it starting from 50% to 100% would be considered as a pass, anything between 0 to 49 will be considered as a fail. So having mentioned these set of constraints, if the customer is able to test, then it is called an alpha testing, and that too specifically if the customer turns up to the developer site and simultaneously both the customer and the developer sits together, if they are able to test it, it is called an alpha testing. Alpha testing may be started when formal testing process is near completion. The other class of testing is beta testing. Beta tests are conducted by the customers or end users at their sites. This is something which is variant from the previous slide which we have looked at. In the previous slide, with alpha testing we have said clearly that alpha testing is done at the developer site with the help of the customer, whereas beta testing is done at the side of the customer or end users in their own sites. Beta testing is conducted in a real environment that cannot be controlled by a developer, where developer will not give you any suggestion on how it will work. Instead, the customer on his own will consider a real world environment and test it of his own. So the customers are expected to report failures, if any, to the company. After receiving such a failure report, developers modify the code, fix the bug, and prepare the product for final release. So any certain errors that was pointed out by the customer by use of this beta testing scenario, then it will be referred to the corresponding developer at the developer site, and corresponding rectification will be made and will be done and prepared, given back to the customer for next level of testing. You would have seen to certain websites where they have given it for beta testing. Say for example, the rail ticket management system IRCTC has come out with a new version of a site where when we plan for a particular travel, simultaneously all the available trains and the corresponding seats in different classes will be made available. So that particular part was initially given for the customers for their comfortness, flexibility and usability, and it was tested. Any reports given or suggestions given by the customer, if it was thought it could be made adaptable at this site, then it will be comfortable and will be developed at the developer site. The other level of testing would be functional testing, where this functional testing refers to testing which involves only observation of the output for certain input values. There is no attempt to analyze on the code which produces the output. So with regard to the functional testing also, we don't have to analyze on the code, but then we look at certain level of functionality that has been involved as part of the code. Now you could recall in one of the discussions that I have made, I was mentioning about function point analysis, the importance of function point analysis, where I have referred to saying input, output, process have been referred, and within the process we consider query, external input, external output, internal logic files and external interface files have also been considered. So we may have to analyze on these functional aspects apart from what exactly is being replicated as a code. So we try to ignore the internal structure of the code as part of functional testing. Therefore, functional testing is also referred to as a black box testing, in which contents of the black box are not known. System is basically being tested for the different level of functionalities having provided. Say at the high level, any certain thing which turns up to them, any top level management will look at the policy activities, and the next level of management will look at how it is to be developed. So as a policy decision, what is that a customer expects from this particular site alone will be referred. Say for the student result management system which I have been considering with, as far as students are concerned, they will be looking at every subject and how much they have scored and with internal and external marks, but looking at from the parents' perspective, parents will not look at the complete regulation and the curriculum. Instead, they will look at whether the student has secured a minimum of internal and the external marks. So in their point of view, it is just a mark which gives you a clear detail of a black box, where the structure of the coding has not been considered. Instead, we will be able to consider only the functionality of the system. Another type of black box testing is supposed to be a boundary value analysis, which I have clearly told you how we have to test this boundary value analysis. The basic idea of boundary value analysis is to use input variable values at their minimum, just above the minimum, and nominal value just below their maximum and at their maximum. I have considered an example wherein I have said to find a number between 0, 100, where the minimum has been fixed with 0, just above minimum has been fixed with 1, a nominal value we have considered was 50, just below their maximum was 99, and at their maximum was 100. So all the values that I was able to indicate was present well within the range, and any value to be tested is within the boundary that we were about to specify. Thus, a boundary value analysis test cases are obtained by holding the values of all but one variable at their nominal values and letting that variable assume its extreme values. There is another class of testing which is called equivalence class testing. In this method, input domain of a program is partitioned into a finite number of equivalence classes such that one can reasonably assume but not be absolutely sure that the test of a representative value of each class is equivalent to a test of any other value. That is, for your better understanding, if one test case in a class detects an error, all the other test cases in the class would be expected to find the same error. Conversely, if a test case did not detect any error, we would expect that no other test case in that particular class would find the error. So, as we have discussed in two different cases, we will cluster all group of independent test cases into one group. Say, if suppose I take out a particular variable from that group, and if it is found to be error sum, then all the other values that are existing in that particular class will exhibit the same quantum of error. If from the other group, if one variable has been selected and it was found to not to have any error, then it means those values that are within that does not contain any part of error. So, that is with equivalence class testing, and the next level of testing being decision table based testing. These decision tables are useful for describing situations in which a number of combination of actions are taken under varying set of conditions. I repeat, it describes situations in which a number of combination of actions are taken under varying set of conditions. So, there are four portions of a decision table, namely there will be a condition stub, there will be an action stub, there will be condition entries and action entries which will be separately labeled as part of this decision table entries. Say for example, if I am asking you to write a program to find whether a given set of three values, say a comma b comma c, can well be formed as a triangle. Say in this particular class, I am be giving three variables a, b, c. Although I would say that these three different values of a, b and c are three different variables, it is not just that we can derive from here directly 4n plus 1, 6n plus 1 or 5 to the power n, as of which I have referred boundary value analysis or robust or worst case testings can be done. Instead, my point of explanation is particular to finding out whether these values make up a triangle. So, my question lies well within the limit of saying whether all the three values that I mentioned in terms of A, B and C become three lines of a triangle. Say for example, I draw a line of A which is 10 centimeter, another line of B which is 5 centimeter, another line of C which is 6 centimeter. If those values represent three different combinations, can this be a triangle? In such cases, what type of triangle it is? So, those type of questions will deliberately come into picture by mentioning only the three values whether they will make up a triangle. This can not be triangle at some times, but it can be triangle with different shapes also. Say a triangle is not only of this shape, a triangle can be equilateral, a triangle can be rectangular, a triangle can be right angled, a triangle can be isosceles, and many other such triangles exist. So, our intention may be on something that all these three values whether it leads to a shape of a triangle. Let us go in for a short break. Welcome back after the break. Before the break, I was mentioning about decision tree based testing, where a simple problem has been considered. So, for making up a decision on three given input values, say A, B and C, whether I would be able to find and judge all these three values make up a triangle. I am writing certain conditions here. If A is not equal to B and B is not equal to C, and this does not make up a triangle, is a simplistic condition which we can derive in the beginning. Having mentioned all these three values, it may not form a triangle, it can be some other shape also. That specific constraint, I will be coming to a conclusion saying it is not a triangle. Whereas if A is equal to B is equal to C is one other constraint which I am considering, where I would like to construct an equilateral triangle. If I post A is equal to B, B is equal to C and A is equal to C as three different constraints, satisfying any two conditions of this would make out to what type of triangle, and satisfying the other condition would make up to what class of triangle. Initially, by looking at the problem by in turn and by looking at only the variables A, B and C, whether I will be able to make up with what are the classes of triangle that exist, and it will be deliberate to explain those sort of classes. And you can ask me an interesting question here. By looking at these three variables, will I be able to say whether it is an equilateral triangle or a right angle triangle or an isosceles triangle or so? It in turn looks at the angle also. So these are to be the conditions that will be involved as part of this exercise. As I have told you in the previous slide, this particular decision tables require condition stub and the corresponding action stubs. So by clearly looking at the entire problem, my condition stubs are to derive whatever actions that I would require as part of the triangle. Say my value of A, B and C, I said this would kindly indicate whether this becomes a part of a triangle. So my first condition being, if A is not equal to B is not equal to C, I mention it saying this is not a triangle at all. So not a part of a triangle becomes an action stub first. And any further condition that I would like to check, say A is equal to B is equal to C, if in case if all the angle matches, I say it as an equilateral triangle. So corresponding condition need to be mentioned as question 2, and corresponding mention on a right angle triangle, I will write a condition stub on top of it, and corresponding mention on an isosceles triangle, I will mention a query on top of it. So the understanding is quite clear. We will have two different conditions, one is a condition stub, the other one being an action stub. So there will be a separation. On a condition check of if A is not equal to B, not equal to C, will this be an triangle? That becomes a first question. This is not a triangle that I am trying to mention. If A equal to B equal to C, this becomes equilateral triangle. I mention yes. If A equal to B, I say yes, and it becomes right angle triangle. So likewise, I try to proceed in future steps wherein I say, having framed up this condition, this action holds to be true. As we write, if A then B. Likewise, this is a condition on which case B is mentioned to be a true. So having considered this, we could able to draw certain test cases which was basically again referred as a black box testing and again satisfies to certain limitations of the constraints. There is another technique which is called cause effect graphing technique, where this cause effect graphing technique is a technique that aids in selecting in a systematic way a high yield set of test cases. It is a systematic method of generating test cases representing a combination of conditions. And there is another level of testing which is called special value testing. It is probably the most widely practiced form of functional testing. It is the most intuitive and least uniform type of testing. A special value testing occurs when a tester uses his or her domain knowledge, experience with similar programs of same type, and information about soft spots to devise test cases. At certain cases, out of a programmer's experience, they might come across with certain test cases. Why don't we test it with this value so that it is, in my opinion, this might lead to an error. So at this juncture, I wish to make clear that I have posted 5 different questions which was of a defect, mistake, error, flaw and a bug. Anything that was run as part of a program, we call those errors as bug in terms of a software coding. Anything which we find it in terms of while coding, in terms of the syntax, we will say it as a mistake. Anything that has been noticed at the customer site, it will be pointed out as defect. So on trying to map between all these words, all these 5 different, although it is meant to be a variant set of words, it is all similar when it has been spelled. So this special value of testing occurs when a tester uses his or her own domain knowledge. He or she might be specialized in her own domain knowledge and the experience in terms of working on similar projects, and I am trying to identify those soft spots. The soft spots are something that we consider that might give an error. The other part of testing is being structural testing. So far, up to the special value testing, whatever we have looked at was coming under the component of black box testing. It is primarily because we haven't looked at any part of the code till we deal with black box testing. So structural testing internally says it should be a part of a code. So code obviously is being a part of the structural testing. So a complementary approach to functional testing is called a structural testing or a white box testing. In contrast, when you compare it with the functional testing, structural testing varies. Functional testing would test only on the black box values. It need not look at the structure, it just have to look at only the functional aspects of the system, whereas structural testing, by looking at the entire content of the program, we may have to proceed. So it permits us to examine the internal structure of the program. If we want to look into the program, examine the code and watch it as it runs. So this activity is dynamic and is about testing a running program, and therefore it is called a dynamic white box testing. Any program that is said to be a dynamic white box testing, it means while running, if it comes across all the defects and all the errors, if it is able to clear it off while it has been run or compiled, it is called a dynamic white box testing. So if we want to test the program without running it, meaning thereby examining and reviewing it, then it is a structural testing. Other point of testing is called path testing, where we will initially draw a graph for every statement of code that we write. Thereby it was able to identify how many independent paths that we may have to go. So path testing is the name given to a group of test techniques based on judicially selecting a set of test paths through the program. If the set of paths is properly chosen, then it means that we have achieved some measure of test thoroughness. This type of testing involves generating a set of paths that will cover every branch in the program, finding a set of test cases that will execute every path in the set of program paths. So my initial intention is to draw a graph and to find out how many independent paths exist in that particular graph. After identification of those independent paths, I will be able to cover with minimum set of test cases for every independent path that I have drawn. So thereby I get into another field which is called cyclomatic complexity, which is also a particular path of path based testing. This is also referred to as structural complexity because it is given internal view of the code. This approach is used to find the number of independent paths through a program. This provides us an upper bound for the number of tests that must be conducted to ensure that all statements have been executed at least once and every condition have been executed on its true and false side. This most of you would have experienced when you are about to run a C programming. Most of the times when we come across certain list of errors, we simply press an F5 button which will take you with every statement of code. So once having typed a void main, it takes you to the floor parenthesis that we have represented. Then it goes to the variable declaration, then it goes to the printf, scanf. So every line, every statement of a line of code is being highlighted with a white box which would indicate how the program flows, how the execution or the compilation of that particular program is being carried. So cyclomatic complexity will give you that particular intention, and apart from that, how many independent paths that we have come across will also be tested. Summary: in this particular session we have looked at two different classes of testing, black box and white box, which we have mentioned at different types of testing. Alpha testing, beta testing, functional testing, boundary value analysis, equivalence class testing, decision tree based testing. These functional, boundary value, equivalence class, decision tree based testing comes under the criteria of black box testing, whereas structural and path based testing, which I have explained for this session, is a part of white box testing, because we generally differentiate between the functionality and the structure of the code. So we look at the functionality in boundary value, equivalence class and decision tree, whereas for structural and path based testing we look at the codes. Questions for this session: how do you differentiate between white box and black box testing? And how do you differentiate between alpha and beta testing? Highlight the usefulness of decision tree based testing. Thank you.